In this lecture, we are going to discuss about second application of Gauss law. You can see on the board heading electric field due to an infinite plane sheet of charge. It means if we have one infinite plane sheet of charge, this is an infinite plane sheet, this sheet are fully charged. Okay, you can see here, and there is a surface charge density sigma, and we can consider the area of this plane sheet is capital A. We can consider like this. Is it okay or not? If suppose that we need to find electric field, resultant electric field formula, so what we can do? So we can take one small area, small dA. Here I wrote now this one is small cross sectional area we are considering here, like this one. Okay, so from this point we are going to consider one external point here, like this, here to here. This one is a r distance. At r distance we are going to be take one point P. What point we are going to take? P. So it means from this sheet, it means if suppose that we are taking like this, suppose that we have this one sheet. Okay, this sheet I am going to show to you. This one we have a one plane sheet, for example. Yes or no? So for this front, this one front. Okay now. So front, if we are going to be discussed, so we are going to be consider one point P here at distance r. Same for the front sheet. Similarly, we are going to consider for the back sheet also. So this is a front, okay, and this is a back. So here we are going to take two we can tell here, this one first front and back front. Okay now. So they are having a two faces of this sheet, front face and back face. So for the front face, if we are going to consider r distance at point P, so we can find here electric field. Okay now. So electric field also we can consider here. Similarly, if we are going to consider back side, so here we are taking that P dash. So this is also distance r. Distance are same. Both side distance are same. Is it okay or not? If distance are same, it means as we can get the electric field here, same we will consider here. So electric field means we are taking distance and this is a charged. Okay, yes or no? So we are going to consider electric field at point P. So we will consider electric field at point P. So before that, if we are going to be consider here one small elementary area, so we are going to be construct one Gaussian surface. This is a Gaussian surface. Okay, and with the help of that Gauss, what we need to consider? We need to calculate, either we need to consider electric flux. What we need to consider? Electric flux. Electric flux means numbers of electric field lines. How much numbers of electric field lines are going to be passing through this cross-sectional area. So for this direction, if suppose we are going to be consider electric field, so direction will be this side, like this. This is the electric field direction. So area element, if you are going to take, so it will be also same direction. It means dA. Similarly, if you are going to take back side, you are going to take back side, so it means here also it will be that electric field like this, and elementary area we can consider like this. It means both has the same direction. Yes or no? Elementary area and this one electric field, so there is an angle between them is a 0 degree. So we will calculate that first electric flux due to this cross sectional area. It means for this front face, and second things for the back face. Yes or no? Front face of this sheet and back face of this sheet. So what we can write here, if suppose that we are going to be write, so how we can write? So for the small elements area we are going to be consider, so it means we can write here d phi E is equal to, okay, so what we can write here, d phi E is equal to, we can write here d phi E1 plus d phi E2. So E1 E2 means E means electric field, but d phi E means that electric flux. Electric flux means that due to that small elementary area. So if we are going to consider it like this, so it means if suppose that we are going to get total electric flux, two words is there. Electric flux means numbers of electric field line are passing through any cross sectional area. Second is the electric field. Electric field means that is we are going to find the intensity of that charge at certain point or that certain distance. So there is a point P. Is it okay or not? So now if we are going to consider total electric flux, So it means we can integrate, there is a closed integral d phi e, okay, is equal to closed integral of the for the surface first. It means surface first means front surface, yes or no, front face we can also say. So here we can write here, okay, so we can write here, okay, d phi, okay, like this. And for the second surface again we are going to write d phi e. Why we are writing here d phi e? D phi is same as the same conditions, because distance are same. Electric field, as you will consider this point, same you will take this point, because of distances are same. Is it okay or not? But we need to calculate that electric flux. So electric flux means numbers of electric field line passing through this cross sectional area, numbers of electric flux passing through this cross sectional area. Is it okay or not? Very good. So now we can write here, after this one, so phi e is equal to, here we are going to write means, so we can write here E dot dA like this for the first front surface, and for the back surface also we can write E dot dA. Is it okay or not? And finally we are going to write like this. So E dot dA means EDA cos theta. So you can write for the first front face, it means EDA cos theta, plus for the second face back side it means EDA cos theta. So cos theta means theta is also here, theta is also, it means here also theta will be 0 degree and back side also theta will be 0 degree. Theta means angle between electric field and elementary area. So now you can see here, okay. So finally you can write here phi e is equal to, you can write, so this is a closed integral for the first surface, so it will be EDA, and similarly second surface EDA. Yes or no? So both have the same, okay. So if both are same means what we can write here, we can write here, so phi e is equal to, we can write 2 closed integral of the, we can write EDA like this. So we can write here phi e is equal to 2 e and that closed integral of that area element like this dA. Yes or no? So we know very well, if suppose that we are going to be take like this, a closed integral of the area element like this, element is small, so small adding, so you will take complete capital A. So now if you are going to be take complete A, so like this you can write phi e is equal to 2EA. So 2EA means this is the electric flux. So you can say this one equation number first. Till here any doubt? No doubt, okay. So after this one, if we are going to be make some arrangement, so you know very well this is the application of Gauss law. Any doubt? No doubt. This is the application of Gauss law. If application of Gauss law means according to the application of the Gauss law, if this is the application of Gauss law, so it means Gauss law we are going to apply here. Gauss law we are going to apply here means, so what is the electric flux formula? So we are going to apply that Gauss law, okay, from the Gauss law. So we know very well electric flux is always equal to the Q upon epsilon naught. Okay, 1 upon epsilon naught times the total charge. Is it okay? So here charge is a Q, but here is the surface charge density. Here is the charge is there, here is the surface charge density. So we need to convert this charge into that surface charge density. So we know very well surface charge density sigma means Q upon A. It means charge per unit area is called surface charge density. If charge per unit area is called surface charge density, so we can also write here, so Q is equal to sigma A. Is it okay or not? So this one, so we can place here. So finally we can write phi E is equal to sigma A divided by epsilon naught. So this is a, you can say, equation number 2. Is it okay or not? So this is also phi electric flux and this is also phi electric flux. So now you can compare both equation. If you are going to compare both equation, so from equation first and second, from the equation first and second, if you are going to be consider means, so you can write here 2EA is equal to sigma A upon epsilon naught. So A will cancel. So finally you can write here E is equal to sigma upon 2 epsilon naught. So this is a A, it means this is a electric field formula, unit will be Newton per Coulomb. So which is a required formula? What is that one? Required formula. Very easy derivation is there. You should just care about this one. So how we can consider that for here, this one first you consider electric field at point P. So electric field at point here, both will be same. This side also will be same, this side also will be same. You are taking that one distance, so you are considering electric field. But if you are taking one elementary area, either cross sectional area, so you are going to be considered that electric flux. Is it okay or not? So for that one, you are going to be consider one Gaussian surface. So Gaussian surface, you consider electric flux here due to that front face of this sheet, and electric flux this cross sectional area due to back front of this sheet. Is it okay or not? After that, you added both, and after addition you got one combination formula. After that, you apply something concept there, and you got that final explanations, final derivation, final equation. Is it okay or not? Till here, if you have any query, any doubt, any problem, you can give the comment also, and you can just join the WhatsApp